I'm Bogart, and I'm a PhD student in the School of Interactive Arts Technology at Simon Fraser University in Vancouver. And I'm here at Elektra exhibiting my dreaming machine, which is my guess at, or my starting point for what it could mean, or imagining what it could mean for a machine to dream. So this particular project is in the beginning of development. Although we call it number 2, it sounds like maybe it could be more complete. But 2, for me, in this case, is really at the beginning of what could be my life's work of exploring cognition as it is in humans and how that could be used in computers. So I consider it a site-specific artwork, meaning that the artwork itself relates to its context in some way. This particular piece, Dream Machine number 2, has a camera that's on the 2nd level here at the Cinematheque, and it's capturing images of Maisonneuve and a little bit of Saint-Denis through the window. All of those images are organized using an artificial intelligence, and that artificial intelligence creates a grid of images where images that are similar to each other are close by and images that are very different from each other are far apart. So what happens is this artificial intelligence makes a kind of collage of all of the images. Then when the camera looks at something it's seen before or something new, the capturing of the new image stimulates its field of memory, this grid of images. The image most similar to that is what we see on the screen behind me. So in the middle we have the image that was most similar to what the camera last saw. Then what happens is that image that we see in the center of the frame, it stimulates one of its 8 neighbors, which is most similar to it. And then it stimulates one of its 8 neighbors, which is most similar to it, and so on and so forth. So this grid of images, in this grid of images, a daydream is a kind of pathway or trajectory through space, through the space of images, showing you a sequence piece by piece. So what we see on the screen is each activated memory and the 8 of its most similar neighbors in the map. So those are the 8 images you see kind of around. So Dream Machine is closest to related to my master's project, which was Memory Association Machine. And that was really the beginning of thinking about site-specific art in a computational context. And so the idea of that was very, very simple. How could I make a site-specific installation where I have almost no impact on how the site is used in the construction of some kind of art or representation? So start off being an attempt for me to erase myself in order for the autonomy or agency of the machine itself to have more emphasis. It turns out that is actually a bit of a paradox, because in order to have the machine have more autonomy and have more behavior that it's its own, you actually have to implement more processes that enable that agency. And so instead of thinking about a site-specific artwork that's a painting that, say, has certain thematic elements that relate to the world in which the painting is installed, I'm moving rather than creating an image like this that we see behind me, I create a process that the result of which is this image. So for me, the artwork isn't just the image, isn't just the installation, but it's really a combination of everything. But the centerpiece that connects the world, the context, the site, to the representation or the image is this process, and it's that process which I think is the core of the artwork. So in artificial intelligence, there's kind of 2 camps of logic. One is you give all the knowledge you can to a machine and then let it reason about that. So in that case, you really, they kind of call it that there's explicit representation. So the computer maybe even has a language, and you program the computer using a language to say, if you see a cat, then associate it with other cats, or if you see a ball, associate it with other balls. That doesn't really work because the computer doesn't know what a ball or a cat is, so that's one problem. In the whole other camp of artificial intelligence, which is like artificial life, unsupervised artificial intelligence, instead of telling the computer what to know, what the truth is, what the right answer is, you leave the machine. They're kind of like algorithms. They're not evolutionary algorithms, that is, algorithms based on DNA and survival, but there's something similar in that they're structures that kind of grow and transform over time in response to the input you give them. So really, in this case, the artificial intelligence only knows difference. So what it does is each image is broken down to a kind of simplified form, and all it does is compare how different these two simplified forms are. If they're really different, then they end up far apart on the map. If they're really similar, they end up close by. But this particular algorithm that I'm using, a self-organizing map, actually works very poorly when it comes to continuously changing data. When it never sees the same image twice, but every day, every time it moves, the lighting's changed, the weather's changed, somebody else came by, then all of a sudden they become more abstract. So actually the image that we're seeing behind me, as it's going through this propagation, you'll notice that all the images we see on the screen aren't always exactly the same, but they're somewhere between being completely organized and being totally random. So it's like the machine's always attempting to make sense of a world that it's hopeless to make sense of. And maybe that's the same thing that humans go through. I mean, we always have these tools. We have models, and we have narratives, and we have ways of making the world make sense, because maybe it doesn't, and it's always changing. And so I think it's a similar kind of process. In this Dream Machine number 2, one of the biggest problems is that the particulars, so the first version of Dream Machine, which was called Memory Association Machine, had 3 screens. One was what the camera saw, another one was this map of all of the images in its entire experience, and then the last one was only one image from the sequence of free associations. The problem was that people don't see the world in this way of, oh, there is something, and we're going to only remember that entire image, that entire frame. We're going to take pieces of it. We're going to remember the face of somebody. We're going to remember the posture of somebody. So the work on Dream Machine number 3, which I'm starting now in my PhD, one of the first things I'm starting with is a perceptual system. So rather than just a camera taking a photograph and us seeing a photograph, how could that process of perception be more similar to how a human or a mammal actually sees? And so the idea behind that is that rather than a dream being composed of whole frames, it would be composed of individual objects. So for example, if there's a car driving down the street and then the camera moves over and then there's a building or a sidewalk or something, in theory it would be able to see the car as separate and then dream about a car on the building or dream about a car on the sidewalk, and something that we would associate, and that's actually something that happens a lot in dreams, is that multiple memories get combined, and they call them hybrid characters. Like when you have a dream where you have a character or somebody in the dream who looks like one person, but you know in your dream is actually somebody else. And that is only possible because our brains are amazing at reorganizing things in a very particular, complex, interesting way. And so part of that subtlety of being able to combine things is where Dream Machine number 3 is going. In addition to that is right now Dream Machine number 2 stays awake until 6 a.m. and goes to sleep at 6 p.m. and that's it. Very, very simple. I would like it to actually have a measure of how stimulated it is by the world. So the more stimulated it would be, the more likely it would be to wake up. If maybe it's a gray day, and for some reason the camera's only looking at the concrete on the bottom of the road, it always looks the same, maybe it would just doze off and fall asleep and have a little dream. So the idea is to have a model of circadian rhythms so that the machine would have a sleep and wake cycle that would, in theory, be tuned to the world in which we live, and hopefully be similar to how humans, when we stay awake and when we decide to go to sleep.